Okay, hello everyone. Welcome to the Physics 221 Exam 3 prep party. And we will start with the multiple choice questions. You can hear me, yes? And we will start with question number 1. Okay, so it's telling that an exercise ball of mass 2.2, mass of 2.2 kilogram fall from a height of 1.9, height of 1.9 meter, and rebound to the height. Okay, so this is going to be initial height, yes? The final height when it's rebound is going to be 1.3 meter, yep. It is in contact with the floor for 8 milliseconds. So this ball, when it's dropping, okay, it's touch the ground, okay, and the contact time it is 8 millisecond. How we can write the 8 millisecond? 8 millisecond, or it's gonna be 8 times 10 to the power of -3 second. Okay, so and it's asking to just calculate these part from A to B. Okay, so let me just draw the situation here. So again, we have a ground, yes, and the ball of 2.2 kilogram, we are dropping it from this height, which is 1.9. The ball reached the ground, yes, good, and then bounce back to this height, which is 1.3 meter. Okay, so and it's telling that at this point the contact point, when it's here, the contact point between the ground and earth, it is 8 millisecond, or 8 times to the power of 10 second. Okay, so what is its velocity just before part A? What is its velocity just before it's hit the floor? What do you think? What we can do? You know, on the top we have it's dropping, yes, and then we can use the kinematic equation, or we can use the dynamic equation, or the conservation of energy law. Okay, so when it's on the top, what kind of energy we have?
um, have like
Potential energy,
potential,
yes,
gravitational potential.
gravitational potential. It is the mgh, yep. When it's about to hit the ground, yes, okay, because we would like to see at what velocity hit the ground. Okay, so the velocity before hitting the ground, so it means that we can use the kinetic energy here to find the velocity, yes, because here when it's about to reach the ground, it does have a kinetic energy, no potential energy, yes, no potential energy. But when it's on the top, the kinetic energy is 0, yes, because it's dropped. We call this number 1, yes, and then in this situation number 2. So it means that energy at situation number 1 should be energy at situation number 2. Yep. What kind of energy we have in situation number 1? We just have potential energy. What kind of energy we have in situation number 2? We have just kinetic energy. Okay. So, and we already know that the potential energy is mgh, yes, and kinetic energy is 1 over 2m velocity squared. Okay, so m cancel each other. So if I just solve this for v, because we are supposed to calculate the velocity, yep. Okay, if I solve it for v. When I solve it for v, is gonna be 2gh, square root of 2gh, yep. So And this v is the velocity before uh, touching the ground, yes? Or hitting the ground. So what is this velocity? We can calculate 2 times 9.8. What is the height? 1.9. Yep. Do you have a calculator? Do you have a calculator? Can you calculate this number?
6.10.
6.10, yes? Okay, so this is going to be the velocity before hitting the ground. Okay, this is part A. So we solve part A, which is going to 6.1 meter per second. So this was part A. Let's do part B here. What is its velocity just after it's leave the floor moving up? I just write it here, You know, the velocity before hitting it is 6.1 meter per second. Is touch the ground, yes, okay, and then it's move up, yes? And it's asking us to calculate this velocity. Okay? So for calculating this velocity, we have a rule, okay, or law, which we call it impulse momentum theorem. Yes? What is the impulse momentum? It means that J equal changes of momentum. What is the J? F delta T equal PF minus PI. Yep. What is the PF momentum after, jumping, bouncing off? Okay. So PI momentum just before hitting the ground. Yep. Okay. So F is the force which is exerted on the ball. What kind of force will be exerted on the ball? Okay, when it's touching the ground, okay, we have a normal force, yes, and force of gravity, yes, okay. So the ball receive a force from the ground, and this force is normal force, and the normal force is equal to the weight of the object, yes. So again, when it's touching the ground, as long as it's not touching the ground, okay, is the gravitational force, yes. Okay, when it's touching the ground, we will have a normal force, and this normal force, because the system is in equilibrium, okay, when it's touching, okay, it's going to be equal to the weight of the moving ball. Yep. So, and then this F is going to be the normal force. Good. So, what I can do here, I can say F is mg. What is the delta T? Change in time, okay, which is the contact time, which is 8.8 times 10 to the power of -3 seconds, yes, equal mass time the velocity, final velocity minus mass time, let's say initial velocity, yes. This was the initial velocity. This is final velocity, which we don't know. We can calculate the good. So what we can do, we can just factor m and then cancel it. So now we have 9.8 times 8 times 10 to the power of -3, yep, equal V final, we don't know, minus V initial is 6.1, yes? Okay. Okay, but we need to know that, okay, so this F is the negative F, okay, we just need to, because the impulse, when the impulse is exerted, yes, uh, no, the impulse is correct, that the force is correct, okay, but the velocity here, because it's downward, yes, see here, the velocity is downward, okay, we need to put it with its sign, okay, so, yep, okay, so the velocity is gonna be VF minus, 6.1, yes, okay, because the initial velocity is downward. So if we rewrite this, it's gonna be 9.8 times a to the power of negative 3 equal VF plus 6.1, okay? So VF will be 9.8 times a 10 to the power of negative 3 minus 6.1. Okay, calculate this, please. Yeah, just multiply 9.8 times 8.
I got -6.02.
Okay, let me just consider to not calculate the velocity from this,
Okay.
because probably, okay, when we are talking about this force, there might be other force as well, okay? So normal and the friction force. So what I do here, okay, I'll just erase this, okay? So it doesn't mean that this is wrong, okay? Because your instructor is telling that follow this way, we need to use again conservation of energy because we know how high it goes, okay? How high it goes, we can calculate the velocity again by using the conservation of energy. So let me just erase this. Because we don't know what kind of force is exact, because we will have a normal force plus, on other dissipative force, okay, so as well, so that's why we need to be a little. So part B, because we know that, the velocity, when it's jump back, yes, jump up, the height is going to be 1.3. So what kind of energy we have? We have a potential energy. Before leaving the ground, yes, we will have a kinetic energy, yes?
Right.
Again, energy is conserved here. Let's call this is number 1 again. This is number 2. Energy at 1 is equal energy at 2, yes?
Yes.
Kinetic energy equal to potential energy. Good. So kinetic energy is going to be 1 over 2 m velocity squared. Potential energy is going to be mgh. M and M cancel each other. So again, we are supposed to find a V before leaving the ground, yes? So V is gonna be 2gh square root of 2gh. Okay, so V after leaving the ground, yes? So it's gonna be 2 times 9.8 times, what is the height? Now this time the height is 1.3, yep? 1.3. So calculate the velocity here.
5.05.
5.05, yeah, 5.05 meter per second. Perfect. So before hitting, the velocity is 6.1, yes? After hitting, the velocity is 5.50. Good. I can use these, okay, and calculate the part C. C, again, I'll just move this way. Again, see here, I draw this. What is the velocity here? 6.1. Now it's moving up, yes? What was the velocity? 5.05 meter per second. For calculating the part C, I can use, okay, impulse momentum theorem right now. Good. J is equal delta P, okay? So this is going to be final. This is going to be the initial. So again, J is F time delta T equal to delta P is going to be mass BF, yes, minus mass VI. Okay. So because we are supposed to find the average force of impulse, the average force, okay, divide both sides by delta T is going to be MVF minus delta T. Yep. I just factored them. So VF is positive 5.05 meter per second. How about VI? If we need to put the sign, okay, it's going to be negative, yes?
Yes.
Negative 6.1 meter per second because it's downward. We put the V final and V initial with their sign. So what is the mass here? 2.2, yep. Time, what is the VF? 5.05 minus 6.1, okay? Divided by, what is the delta T? A times 10 to the power of negative 3. So this is going to be average force. And this average force is going to be the normal force I said, okay? Plus if there is a dissipative force or all these forces. So calculate this. Okay, let me just 2.2, 5.05 plus 6.1. Yes, divided by 8 times 10 to the power of negative 3.
3066.
3066.
Yes. 0.25.
Okay, so let me just plus 6.1 times 2.2 divided by 8 times, yes, you are 3066.25 Newton. Yep. So it's telling that how much energy is lost, yes? Energy is being lost, yes? How we can do energy? Okay, again, here, the energy, we can calculate the energy, yep, which is, what is the kinetic energy here? 1 over 2 m velocity squared, yes? And energy here is 1 over 2 m velocity squared. But because the velocity are different, so it means that the energy, the energy is lost. How we can calculate the energy loss? Energy loss, it's going to be kinetic energy before hitting, yes, minus kinetic energy after leaving the ground, yes?
Yes.
So how we can do this? So again, let me just change the color. So energy loss will be 1 over 2 mass velocity before, 1 over 2 mass velocity after. Yep. 1 over 2. What is the mass? 2.2. What is the velocity before? 6.1 squared minus 1 over 2, 2.2, yes? What is the velocity when it's leaving the ground? Okay, 5.05 power of 2. Yep. If I just simplify this, it's going to be 1.1, 6.1 squared, yes? Minus 5.05 squared. Okay. Go ahead and calculate this. Let me just see if we have anyone online. Yep. No one online.
Twelve point eight eight.
Hmm?
12.88.
12.88. 12.88. Okay. 12.88 joule is being lost. You know what exactly happening? Because we are assuming that the energy is conserved, yes? But the energy before hitting and the energy after, jumping, yes, bouncing are different. What happened? Energy is being lost, okay? By when it's touching the ground, okay, because of this force, the space force, okay, the energy is being lost. Okay, so and then we can just subtract the energy, okay, before and after, okay, and then this is gonna be the energy that is lost during the interaction between with the floor. Good?
Yeah, which is, I think.
Yeah.
Great, it's weird.
So the question. Okay, let me just draw the situation for question. There is a box with a mass of 250 kilogram. Slide down the incline that make an angle of 53. So we have this is a 53. Yep. Okay, and there is a box here. First of all, we need to see what is the direction of the gravitational force. The direction of the gravitational force. Yes, it is. Oh, I would like to draw different color. This is the mg, okay? Or we call it gravitational force. There are other forces as well, okay, but we don't. It's better to draw them first, okay? So normal force is going to be perpendicular, yep. This is a normal force, okay? And if it is sliding down, there will be a friction force in this direction, yep. And what kind of friction force is going to be Fk, or kinetic friction? So here, the part A is asking us to calculate the work is done with the box gravitational force. Okay, so it's asking to calculate the W of mg. Yes. So we need to know what is the work formula. What is the work formula? Work is force time displacement cosine theta. What is this theta? Angle. Yes.
Yeah.
Between force and D. Okay. So let's say if this is a force and this is the motion is in this direction, yeah, the angle is gonna be this theta. Good. What is the direction of the motion here? The direction of the motion is this direction. Good. See? So what if I find the angle between the mg and d? Okay, how can I draw? So I just draw it here. Let's say this is mg, yep. And this is d direction. Good.
Okay.
Yes. This is going to be our theta that we were looking for. So what kind of information we have? So we have this information. So I know that this is 53. Good. And this is 90 degree. Okay. So what is this theta is going to be? The theta is going to be 90 minus 53. Yep. What is the 90 minus 53? Is going to be 27 degree. Okay. Good. Makes sense?
Or it'd be 37.
Oh, 37. Sorry.
But yes.
Good.
Yep.
That's it. So, and I just write, the formula here. See? It's going to be W mg is going to be mg multiplied by d multiplied by cosine of, what is the angle between these two? mg and d. The angle is going to be 37. Yep. Okay, we don't need to find the component of the force of gravity, okay? So we would be able to solve this in different way, okay? But, you know, this one, you have force, you have displacement, find the angle between, okay? I will show you how to find, you know, this work, okay, with other way. Good? So, what is, and go ahead and calculate this. What was the mass? 250 time 9.8, yes?
Yes.
G, what is the D?
Uh, it's, uh, it's
20 meters. Time cosine 37. Make sure that your make sure that your degree, the mode is in degree. Calculate this.
times 37 is 39,133.14.
114. Good. So let me just show you how to use the other way, okay, to calculate this. Okay, let me just draw. We will back to this. Okay, so this is gonna be the second way of calculating. Okay, this was 53, yep. And let me just, I just draw mg for now. Good. Okay. You remember we were supposed to, we would be able to find the component of the, if this is the x-axis and this is the y-axis, yes? This is the x-axis and this is the y-axis, yep. We would be able to find the component of the mg. You remember that?
Yes.
Okay, let me just use different color. We said that this is mg and this is 53, yeah? This is gonna be, yep, mg cosine 53, yep. And then the other one is gonna be mg sine 53, yep.
Yep.
Okay. Now, instead of 1 mg, we have two forces, yes? mg cosine 53 and mg sine 53, yep. It means that we are supposed to calculate the work of two forces. Yes, the work of mg cosine 53, yep, and the work of mg sine 53. Okay, again we use the same formula, f d cosine the angle between, yes. Okay, what is our force here for the first one? What is the force? mg cosine 53, yep. D is the displacement we have, but mg cosine 53, you know, this is mg cosine 53, yes. What is the D? D is in this direction, yep. D is in this direction, okay. What is the angle between these two? 90 degree, yes. What is the cosine 90? 0. Okay. So again, calculate the work of this, again, the work with this the same formula. What is the new F right now? mg sine theta. Yes, mg sine 53. Good. Time d. Okay. What is the cosine between these two? Now we have mg sine 53. And what is the D direction? Exactly at the same direction. Yep. What is the angle between these two? Is 0 degree. Okay. What is the cosine 0? Is 1. So it's going to be mg sine 53 times d. Yep. So what was the m? 250. What is the g? 9.8. What is the sine 53? Just put sine 53. And what is the d is? 20 meter. Yep. Go ahead and calculate this. You will get exactly the same number. Here it was sine 53. Yes. Okay. But the 3,900, 3,900, 133. Yes. Point 14. Yes. 3,000.
913.3.
We got a different number.
I might have accidentally, oh, it is different. I was gonna say it, maybe I just added an extra, but.
Okay, cosine 37 is sine 53. There is no difference. Okay, it should be exactly the same. Okay, so sine. There is a sine here. Okay, don't put cosine.
Okay,
Okay, just calculate one more time.
I put a sign.
250, and the displacement was 20, yes?
Uh, Oh, 20. Oh,
Yep.
that, I put two bags. There we go. 39,133.139.
So probably you just saw calculated this wrong. Can you calculate this one more time? 250 times 9.8.
Those are the same as each other now.
Hmm?
They're the same as each other.
Oh, they are same? Okay.
I put in 2 instead of 20.
Okay, yes. You know, see, we will get the same number, yep. So you are able to use the two-way, okay, to calculate which one is you feel comfortable. You can find the component of the mg, or no, just mg and d, find the angle. Good. So this was part A with two methods. Now back to this problem. Part B is asking find the work done by the friction force. Okay, good. So we have a friction force. This is the friction force, yes? So again, let me just. Work of friction, yes? Again, I use the same formula. What was the formula? F times D times cosine angle. What is the F? Is the FK. What is the D? Just the D. What is the angle between these two? You know, FK is this way. The D is this way. What is the angle between FK and D? FK? No. The angle between FK and D. You know, see FK, they are opposite direction, yes?
180.
180. So, and then that's it. Okay, what is the FK? FK, you know, we already know that FK is mu K time N, yes? And from unit 2, we know that N is going to be mg cosine 53, yep? Yes or no? Again, these two are equal, yep? Mu K N d cosine 180. So let me just erase this. So WFK is going to be, again, mu K. What was the N? N is mg cosine 53, yes? mg cosine 53 time d time cosine 180. Yep. So what is the WFK? We have mu k. Mu k is 0.25. M is 250. G is 9.8. Cosine 53 time D is 20. And then cosine 180 is -1. Yep. Go ahead and calculate this one. And it makes sense. The friction force work is negative, okay, because the system is losing energy.
Negative 7,372.
Negative 7,000
372.
point
2.
2. Okay. Joule, yes? You multiplied all this number, yes? Cosine 53 as well?
Yeah.
20 and then, okay, good. Okay, this is part B, yep. What was the part C? Find the work which is done with the normal force. Okay, see here, again, this is a normal force, yes, and this is a displacement. What is the angle between the normal force and displacement? You know, this is a normal force, yes? This is displacement, good. What is the angle between these two? No, 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 see? You know, no, normal is perpendicular to the surface, yes? And the box is moving in the direction of the surface. So it means that the angle between these two is, see here, let me just draw one more time. This is perpendicular, normal, yes? And this is D, yep. What is the angle?
90.
90 degrees. Okay, so if I am writing Wn, it's gonna be normal time D time the angle between normal and D, yes? Which is a 90 degree. What is the cosine 90 degree? 0. So the normal force work is 0 joule. Yep. So make sense? So we are just find the C, yep. Okay, find the network. Okay. Add all work together. Yes. The network part D work total is gonna be what? Let me just write it here. Yellow work of MGS, work of friction force, yes, work of normal force. What was the work of MG?
That was. Um,
Okay, we have it here.
yeah.
39, yes. 39133.14 joule plus, this is negative, yes, negative 7372.2 joule, yes, plus 0. Okay, subtract these two number, okay, or add with the negative sign.
$31,768.9.
Okay, W total is gonna be 31,000, yes. How much? 760.9
760.9.
joule, yes. This is the network. Oh, so for part D, how we can calculate the part D? If the initial speed of the box, okay, 2 meter per second, what is the final speed? Yes? Okay. What we can use? We can part E, work kinetic energy. Yep. work, the total work is what? We just calculated. Yep. It is at 31760.9 joule. Delta K, it means that 1 over 2 mv final squared, 1 over 2 mv initial squared. We already have V initial. It is how much? 2 meter per second. Good. Okay, we can calculate the final velocity. 1 over 2, what is the mass? What was the mass? 250, yep. V final squared, 1 over 2, 250, yes. Time 2 power of 2. Good. Okay, go ahead and just simplify this. I think it will be, yeah, just solve for VF.
Square. So, divided by 125 square root. So it's 16.07.
Are you sure?
Right. That's do it again. So squared is equal to 32,260.9 joules. Divided by 125 is 260.9 divided by 125. It's 258.8.
So this is going to be 125, yes, time 4, which is going to be how much?
So square root of that answer, 16.07.
Okay. What was the initial velocity?
16.07.
No, initial velocity was 2 meter per second, yes?
Oh, yeah.
Okay, so VF is going to be 16.07 meter per second. Okay, good. Perfecto. Okay. You can use the kinematic equation, okay? It doesn't matter with the time excluded, time independent, formula or whatever. So let's say, okay, so let me just draw the situation first, okay? So we have a ground, yes? And we have a ball which is shot from this height. Let's say this is the height, which is 1.75 meter, yep. And the spring is compressed, and there is a spring here, and this spring is compressed how much? 17 centimeter, okay. And then when it's released, okay, it will have, so let me just draw like this. A spring is here. When it's released, now the ball is here. Yep. Okay. So here we just have elastic potential energy US. Yep.
Yep.
Okay. And UG, because they are all above the ground. But here we will have UG. Yep. And KE. Good. And what happened to the ball? The ball reach to the ground, and how far it hit the ground? Okay, travel 4 meter horizontally. 4 meter horizontally. And what is the mass of the ball? The mass of the ball is 35 gram or point 0.035 kilogram. Yes.
Yep.
Okay. So we can use the conservation of energy here and here. Okay. So if I'm just trying to write everything that I can. It can help. Okay. So and then see which one I can use later. So here I can say the energy here is equal energy here. I call it E1 and E2. E1 equal E2, it means that US UG equal to UGKE. Yep. UG and UG cancel each other. Yep. So what I have 1 over 2 K X squared equal, what is the energy? 1 over 2 M velocity squared. Good. So again, here I don't have K, I don't have velocity. Okay. So it means that I cannot do anything for now. Okay. So again, I'm just trying to write everything down. Okay. To see which one I can help me to find. So if I find the velocity here, I would be able to plug to here and then calculate the K. Good. So, and how can I calculate the velocity?
X is the delta of displacement.
Hmm?
X is the delta of displacement.
Yeah, delta x is the change of displacement. Okay, but we need to use a coordinate system. Coordinate system. I plug my coordinate system here. So let me just draw. Good. This is my coordinate system. Good. X and Y. Initial and final. Good. At initial point, okay. So what is the xi? 0. What is the yi? Again, 0. Yes, because I put this as origin. Good.
Sure.
0 and 0. Good. And what is the initial velocity in the x-axis? It is just this velocity that I'm trying to calculate. Yep. What is the VIY? We don't have velocity in the y direction. Yes. The initial velocity is the horizontal. Okay. No. Okay. What other information I have? Nothing. Okay. XF. What is the XF? It is 4 meter. Yeah. What is the YF?
75.
No. No.
Zero. What's that? Zero.
No.
Negative.
Perfect. Negative 1 point. Yes. Okay. When ball is here, it is 4 and negative 1.75. Yes. Based on the coordinate system. Good. So what I do here, okay, so I have this. What information I have? That's it. Yep. Okay. So, you know, uh, you remember I can use this formula yf equal, because in the x-axis we have a motion with the constant velocity. In the y-axis we have a motion with the constant acceleration. Good. So in the y-axis I just write this formula yf yi. You need to write all of them, okay, to see which one you can use. Okay. So vi vy vi. Yes. Delta t plus 1 over 2 a y delta t squared. Good. What is the yf? Negative 1.75. What is the yi? 0. What is the initial velocity in the y-axis? I forgot to write. Okay, we don't have initial velocity in the y-axis. Yes, we just have horizontal velocity. Yes, the initial velocity is 0. So this is going to be 0. Good. Plus 1 over 2. What is the acceleration? Negative 9.8. Yes. What is the time? Delta t squared. Good. So delta t is going to be, negative, negative, both cancel each other. So we will have 2 times 1.75, yes, divided by 9.8. Good. So go ahead and calculate this number, delta T. You see what I'm doing? Okay, so
0.5 or 0.60.
0.6 second, yes?
Uh, yeah.
0.6, yes? Okay. This is the time. And how, it means that it takes this amount of time, the ball is from here, yes? From top to the ground. In the x-axis, I can use this formula. xf equal xi plus vix, yes, delta t, yep?
Yeah.
Because there is no acceleration. Okay, I don't write the acceleration part. I just write the first two sentences. What is the xf for? See, what is the xf for? What is the xi? 0. What is the initial velocity in the x-axis? V, yes? What is the time? 0.6. Okay, so V is going to be what? 4 divided by 0.6. Okay, go ahead and calculate this. It's going to be 40 divided by 6 or 20 divided by 3. What is the velocity?
6.67.
6 point,
6.7.
let's say 6.7 meter per second. Velocity is going to be 6.7 meter per second. Good? Okay, so you remember I said, okay, if we plug it here, we are done. 1 over 2 k x squared. X was how much? X was 17 centimeter, yes? When it's compressed. 17 centimeter? 17, let me just,
It is.
yes, 17 centimeters. It's going to be 0.17 meter, yep?
Yep.
So 0.17 meter squared equal 1 over 2. What is the mass of the ball? 0.035, yes? Velocity is 6.7 power of 2. Yep. So if I calculate this, these 1 over 2 cancel each other. So K, it will be 0.035 times 6.7 squared divided by 0.17 squared. Okay, go ahead and calculate this K, please.
$54.
54.4 Newton per meter. Okay?
Yep.
Yeah, this is question number 4 is telling that consider two parks colliding on air. Yes, on an air hockey table. Oh no, it's on an air hockey table. Okay, so as shown, park A has a mass of 0.025 and is moving with this velocity, and it means that the velocity here, let me just change the color, 5 meter per second. Good. And then to the right and collide with the B. The mass of the B is here, which is initially at rest. Okay, so it means that at 0, after the collision, park fly apart with this angle. What is the final speed of the park A? Okay, what is the final speed of the park B? Okay, is this an elastic collision or not? Okay, so let's go over this problem. Okay, so because we don't have time. So before collision, I call I, and then after collision, F. Before, yes, and then after. What is the initial velocity before? It is 5.5 meter per second for, I call it A. Yes, for park A. And in the x-axis, yes. VIA in the y-axis is 0 meter per second. Yep, because it's just have a velocity in x-axis. Good. In the y-axis, no velocity. Yep. And then what I do, VI, V, x-axis is 0. Yes. You know what does it mean when I say VI, BX?
Yeah.
Initial velocity of the at x-axis is 0. Initial velocity of puck B at y-axis again is 0. It means that it's at rest. We call these, okay, after collision, puck B, puck A does have momentum, yes? We call PA, but it does have a, sorry, X component, yes? In X, it will be PAX, yes? In Y, it will be PAY, okay? And how we can calculate the PAX and PAY? Okay, if we say that this is a PA, PAX is going to be PA, yes? Cosine 65. You know, I'm just finding the its X component and Y component, yes? Make sense? PX component is going to be PA cosine 65. PAY is going to be PA sine 65. Good. And the park B, again, x-axis and y-axis. But I forgot to mention, okay, both of them are positive. Why? You know, this is a PIX, yes? It's moving to the right. PIY is moving upward, positive. So park what is this? You know, PB, this is a PB, yes? Again, it's going to be PBX, PBY. Good? PBX is going to be PB cosine 37. And then PBY is going to be negative, yes? Negative PB sine 37. Okay?
Yep.
Good. So these are going to be after collision, yes? Okay, we should know that the momentum of A, good, initial momentum of A, let me just use this. PA and the PB should be same. Elastic doesn't matter, is elastic or inelastic, yes? The momentum should be conserved. Yep. So, but we have 2 dimension, so it means that PAX should be, you know, this is I and, sorry, my bad. PA plus PB before, yes, should be equal PA plus PB after, yep.
Yeah.
And then because it's two-dimensional, okay, so it means that PA plus PB I in x-axis, yes, should be equal to PA plus PB, good. F in the x-axis, this is I, yes, this is F. And PA plus PB I in the y-axis should be PA plus PB F in the y-axis. Good? Make sense? Okay, I'll just go ahead and write everything here. Okay, what is the PIX? Okay, we already have here, yes? It's gonna be mass time velocity. What is the mass of A? Mass of A was mass of A was 0.025, yes? Let me just write it here. Mass of A is 0.025. Mass of B is 0.05. Yep. So for this one, for this part, okay, what I write? Momentum of the A before collision is mass time velocity, yes, in the x-axis. What is the mass of the A? 0.025 times 5.5 plus momentum of the B in the x-axis is what? 0 equal to momentum of the A in the x-axis is PA cosine 65, yes? And the momentum of the, what is the momentum of the B in the x-axis is going to be PB, yes? Cosine 37. Good? Make sense?
Yep.
Okay, just do the same. In the y-axis, okay, you see we don't have any momentum, yep? It's going to be 0, and then momentum of the A in the y-axis, it is PA sine 65, yes? And momentum of the B in the y-axis is negative, yep? PB sine 37. Okay? So we have two equation, two variable, yep? Two equation is this, the equation number 1 and equation number 2. And what are the two variable? PA and PB. Okay? So what I do from here, let me just write with different. I can just find the PA from here, yes? It's gonna be PB sine 37 divided by sine 65. Good? And then just plug these to this equation. Yep. What I do, I just write it down here. 0.25 times 5.5 equal. What is the PA? PA is going to be PB, yes, sine 37 over cosine. Let me just sine 65. What multiplied by cosine 65, yes? Cosine 65 plus PB cosine 37. Okay? So what I do, I just factor this. I just factor PB. Okay, and I know that the cosine over sine is cotangent, yes? Cosine over sine is cotangent 65. And a factor is going to be sine 37 cotangent 65 plus cosine 37. Good? Equal to 0.025 times 5.5. Okay? So PB is going to be 0.025 times 5.5 divided by this value. Sine 37 cotangent 65 plus cosine 37. Yep. Okay, so just calculate this. When you calculate that, okay, so you can calculate the PA. Good?
Yep.
Okay. When you have a PA and PB, good? So you will have everything. Okay, but part B is telling that part C is telling is that elastic collision or not. For finding the elastic collision, okay, so if you want to find out is elastic or inelastic, calculate the energy before and energy after. Okay.
Yep.
So energy before, if I write the kinetic, because we have just kinetic energy, yes? Kinetic energy is 1 over m velocity squared. If I rewrite this, it's going to be p squared over 2m, yep? Kinetic energy before, before, e after. Before, yes? We don't know it's going to be equal or not, okay? So we find the ke before, yes? Just the PA before I over 2MA. Calculate this, yes? And then KE after. What you can do, because you already have PA and PA, okay, PA is squared over 2MA plus PB squared over 2MB. Calculate this one as well. Okay, the pi, it means that the momentum before. Okay, so you have the momentum before. Good.
Yeah.
And then compare these two, ka and ka before, ka after. If they were equal, it is elastic collision. Okay, if ke before is equal ke after, elastic. Otherwise, inelastic. Yes.